Hello everyone. Today I'm going to be graphing the quadratic expression of y equals negative 2x plus 3 squared plus 4. And I'm going to be teaching it to you and how to do it. For the a value, we call it the absolute a value. Our absolute a value is negative 2. Since the a value is negative, this indicates a reflection across the x-axis. So we can actually check that off. And the absolute value a equals 2. Negative 2 indicates a vertical stretch by a factor of 2. This means the parabola will be narrower than the parent function, which is y equals x squared. Now, for our h, which is the negative 3, although here it may appear as x plus 3 in the equation, it's actually equivalent to x minus. Because now the k value is 4. Oh, forgot to add the negative 3. Okay. This results in a vertical translation 4 units upward. Oh, and this is, our h value is the horizontal shift 3 units to the left. So if this was a positive, it would actually be shifted to the right, but it's a negative, so remember, it's always going to be the opposite of what's in the bracket. That's how I remember it. Now we're going to be plotting the parent function. As you guys can see, I've already fast forwarded and plotted the parent function. Our parent function is y equals x squared, and the points are 0, 0, 1, 1, 2, 4, 3, 9. And for the opposite side, it's a negative 1, 1, negative 2, 4, and a negative 3, 9. This is just the basic parent function, which is y equals x squared. So these points form the basic parabola, opening upwards with the vertex at the origin. Now we're going to apply the vertical stretch and reflection. So apply the vertical stretch by a factor of 2 and the reflection over the x-axis. Now this is done by multiplying each y-coordinate by negative 2. So just to get a quick visual, 0, 0 will remain 0, 0, 0, 1, 1 becomes 1, 2, 2, 4 becomes 2, negative 8, 3, 9 becomes 3, 18, 3, negative 18, negative 1, 1 becomes negative 1, negative 2, negative 2, 4 becomes negative 2, 8, negative 2, negative 8. And finally, negative 3, 9 becomes negative 3, negative 18. Okay, now we're going to plot these points. So 1, 1 will become 1, negative 2. Then 2, negative 8. Then 3, negative 18. And then same for that side, so negative 1, negative 2. Negative 2, negative 8. And negative 3, negative 18. Now, we're going to, as you can tell, it's way more narrow than the parent function, and it's actually stretched much more. So that's due to the vertical stretch. Okay, now just to be more specific, this graph applies two transformations, a reflection across the x-axis and the vertical stretch by a factor of 2. That's because I've multiplied all the values, y values, by negative 2. This is y equals negative 2x squared. This shows the reflected and vertically stretched version of the parent parabola. Now, I'm going to apply the horizontal translation. So, since our h value equals negative 3, I will shift every point 3 units to the left. Sorry, continue on. 0, negative 18. And then, negative 4, negative 2. It's going to represent the equation y equals negative 2 x plus 3 squared. I'll apply the vertical translation. So this is our k value. Since k equals 4, I will shift every single point 4 units upwards. So our negative 3, 0 becomes negative 3, 4. 3, 4. Our negative 2, 2 becomes negative 2, 2. And negative 8 becomes negative 1, negative 4. Now, our 0, negative 18 becomes 0, negative 14. 4, negative 2 becomes negative 4, 2. Our negative 5, negative 8 becomes negative 5, negative 4. And our negative 6, negative 18 becomes negative 6, negative 14. So negative 6. It works. So this graph represents the final function of y equals negative 2 x plus 3 squared plus 4. Now that we have the final graph of y equals negative 2 x plus 3 squared plus 4, let's identify all of the key features. We can tell because the a value is negative. In this case, our absolute a is negative 2. Whenever a is negative, the parabola always opens down. And if a is positive, then it opens up. Our vertex is the highest point on the graph, which is the maximum point. In this case, since our parabola is actually opening downward, we have a maximum point, not a minimum. The minimum is only when there is a negative a value. So axis of symmetry is a vertical line that passes through the vertex. So for this parabola, the axis of symmetry equals -3. And for our optimal value, the optimal value is the y value of the vertex. So the optimal value here is y equals 4. Let's find the x-intercepts where the parabola crosses the x-axis. So to find the zeros, we set y equals to 0. We could actually do this one together. So there we have it. Our x-intercept is approximately -1.6, 0, and -4.40. Now, for the y-intercept, the parabola crosses the y-axis. To find it, we actually have to substitute x equals 0 into the equation. So we can also do this one together, which so y equals 0, 14. So the y-intercept is at 0, -14, and is actually divisible on our graph. And that's how you graph the quadratic function of y equals -2 x plus 3 squared plus 4, step by step. We started with the parent function, applied the reflection and vertical stretch, did a horizontal shift to the left, and finished with a vertical shift upwards. We then identified all of the important features like the vertex, the axis of symmetry, the intercepts, and the direction of opening. Bye.